Hi there, my name is Paul Debevec, and I am a senior staff engineer at Google VR and also an adjunct research professor at the University of Southern California's Institute for Creative Technologies.
So you are working on bringing digital actors to life in your research. Talk a little about, first of all, what you did with Blade Runner 2049.
So in Blade Runner 2049, oh my God, amazing film. So honored to have had a chance to contribute to it. We have a device that we've built in our laboratory. That's something we've done about 20 research papers over the years on, called the Lightstage. And it is this sphere of LED lights that are computer controlled with a lot of cameras, and we use it to digitize faces. So we have a lot of applications for it in training and education, but we're right there in Hollywood, and we have the chance to also contribute to visual effects for movies, for video games. And in Blade Runner 2049, the visual effects production asked us if we could do very high resolution documentation and scanning of 4 of the actresses for the film.
And how was your technology specifically used? Did they make the actresses appear differently than they do in real life?
So it's actually really interesting applications of the technology. Our Lightstage can get incredibly high resolution detail down to skin pores and fine creases of the face. We can get different expressions. We can record how it responds to light from every direction. And it's this, as strong of a raw data set about what this person is, what they look like, how they move, that we can deliver to a visual effects company, for example, moving picture company, MPC, and Double Negative, if they're going to create a digital character based on them. And what's super interesting about Blade Runner is that for the 4 actors that we scanned, 2 of them were combined into one of the characters that you see in one way, and 2 of them were combined into another visual effect that you see in a completely different way.
How have you seen, because there's been multiple movies now over the last decade where we're seeing actors being brought back from the dead, we're seeing actors that are currently old appear young. How is this technology that you guys are developing allowing that type of thing that we're seeing with Hollywood movie magic?
Well, the first film that we helped create a transformed version of somebody for was The Curious Case of Benjamin Button. And we actually did a lot of scans, not of Brad Pitt, but actually of an incredibly realistic silicone sculpture that had been made of him as if he were a 70-year-old. And that and the way that lighting played off of it in the Lightstage became part of what the visual effects company Digital Domain used to create the, kind of like the first photoreal digital actor that we've seen in a feature film, almost 10 years ago now. The most recent applications that we're seeing are even more exciting. In Blade Runner 2049, we scanned Sean Young and kind of a stand-in actress named Lauren Peeta. And the data for both of those went to MPC, the visual effects company, who spent about a year creating what I think is basically like the new high watermark for a photoreal digital human, which is the character Rachel that shows up toward the end of the film. And obviously, Sean Young is around 60 years old, absolutely lovely woman, amazing. But even with makeup, even with de-aging effects, that's just too many decades to try to bridge. So Lauren Peeta, who has maybe a very passing resemblance to the young Rachel character, was brought in to provide reference for how skin should reflect light, how the makeup should reflect the illumination, to wear the costume and do the body acting as well, and for some references for performance as well. And then all of this goes into the amazing work by MPC and some of the best animator artists in the world, looking at video capture of the actors, and then in the end actually just keyframe animating every little nuance of that performance. And for me it's interesting because we did the scans for this back in the summer of 2016, and then there's this long waiting period. We process all the data, we deliver it to the visual effects company, and then we just hope it comes out really well. And then I've seen the movie once, so I've had that. It's like about maybe 2 minutes of sequence, and it's like, okay, here it is, and boom, it's like the first thing I look at is like, okay, like, well, does it look like skin? Does it look like the lighting's reflecting? Is it integrated well? Are the eyes okay? Oh my God, the eyes are sometimes just not quite there, and that's bad. But everything was checking out. Like the skin was reflecting light, the eyes were good. And then while I was trying to pay attention to like all these technical things, I had to stop because the Rachel character was acting, she was emoting. And this totally digital, synthetic, apparition that's in front of me just brought me into the performance, and I saw thought behind the eyes. And that's just the result of like MPC hitting out of the park with this amazing work.
How do you see the technology you guys just described morphing and blending moving forward with the performance capture we're seeing more and more in film and video games?
Performance capture has continued to evolve really far at this point, and we still don't have the ability to capture the motion of the surface of a face, either from 200 motion capture markers or for a whole bunch of pixels that are tracked in video. If you're trying to apply that to a different character who's not literally the person that you recorded, like something that is supposed to look exactly like them, it's still a bit too hard for computers to translate the performance of one person to drive another character and have it just work right out of the box and emotionally ring true. It still needs some of those like amazing animators to go in and reinterpret it and fix little ticks and positions and all of that, because the thing that a person would do isn't exactly what they really should have done if their face looked different, if it were a different age, if it were a different kind of creature. So maybe we'll get there, but what I do know is that all of the great performances we've had from digital actors that you see up there, even if there were animators fixing things up, maybe tweaking stuff or reinterpreting a little bit, they end up being successful if and only if the real actor delivered a compelling and good performance to begin with. If you just have to try to make it up out of whole cloth, you really can't do that. You need amazing reference and ideally, just really good work done by real actors.
And what happens when that actor is no longer with us and they're being brought back?
That's a good question. The question is, so like if an actor has passed on and we want to see them again, it's tough. We worked on a project with Pulse Entertainment for the Billboard Music Awards a few years ago. And in this, they created a digital Michael Jackson that performed using one of those kind of Pepper's Ghost reflected, quote unquote, hologram sort of things, done extremely well. And they had a new audio track that there was no video of him performing, but people hadn't heard the song before. So they thought, well, let's create a video for it. Let's create a performance for it. And I was actually astounded. They pulled it off. It was amazing work done by some of the best artists in the world up in the Bay Area who keyframe animated every little bit of Michael Jackson's face. And to do that successfully, they had to just analyze all of the video that they could find of him, of how does he say this word, how does he say this word, how does he move his head this way or this way. They talked to people who had actually worked with him to try to get some sense of how he would have created that. So I think that if you have like an entire person's career to look at and your goal is to put them into a movie for 2 minutes or to create one last song that they really did actually sing and was their own creative stuff, at least from the audio, I think you can do little bits like that. But extending it further into imagining like what's the next phase of their career. I mean, Lady Gaga or Madonna, they like reinvent themselves every couple of years. We could never imagine how an actor would reinvent themselves. We really, I don't think, could figure out how an actor would approach a new character that they had never played in a film before, because that's an incredibly creative process that actually changes the actor in their process of creating that performance. And that's going to be beyond what we can simulate. There just isn't the data for that. We can do little echoes of them. We can do little homages and tributes. We can provide a window for like the new generation to start to look into what they were with their career. But it's just impossible to actually take it into new places.
How are you guys working within the video game space, and how does that connect with what you do in Hollywood?
We started doing work involving photoreal digital actors. I guess the first movie we worked on was Spider-Man 2 in 2004. And then, just to render a face took like overnight with a whole bank of computers back then. And it didn't really seem like it would be possible to render this stuff in real time, 60 frames per second on a video game console, no less. Turns out, people being smart and computers getting faster, there was eventually a convergence. And in 2013, we collaborated with the video game company Activision to create a research test. Can we do a face that we've scanned on the Lightstage and render it in real time in a game engine? And this was called the Digital IRA project. And we worked with our colleague over there, Javier van der Pelen. We used a bunch of scans of our colleague, Ari Shapiro, in all of his facial expressions and a performance capture we did of him. We gave that to Activision, and then their wizards invented real-time skin surface shaders and real-time image-based lighting and ambient occlusion and subsurface scattering. Some amazing work by Jorge Jimenez on the eyes that just reflect and glint incredibly realistically. And in 2013, we were able to show at the SIGGRAPH conference the Digital IRA project that you could actually move the face around, change the lighting, cue different performances. And that was a bit of a breakthrough there. Based on that, Activision ordered a Lightstage from our lab. So we actually built a copy of our own Lightstage, and that's running, actually just about a mile away from us at their studio. They've had some members of our laboratory actually go on and work at Activision and help apply that. And it's been used to scan hundreds of actors for video games now, including, I think a big title coming out is Call of Duty World War II this fall. So all the faces were scanned in a Lightstage system that we built. And there are a couple of other major video game companies that are in the process of getting their own Lightstages as well. So technology is making it possible so that not only will we have some of the things that were only possible in movies appearing in video games interactively in real time, but we're seeing that video game engines are becoming useful for actually creating movies. And once we have this digital human technology that really works and looks just as good as what a digital Rachel or a Benjamin Button would look like, I think it's going to open up amazing new possibilities for filmmakers to create incredible visions at a tiny fraction of the cost of what it takes today.
Yeah, SIGGRAPH this year, Epic Games showed Unreal Engine 4 with a VR real-time demo of a person having a conversation in VR, and it was a virtual person. At the same time, K2SO in the final movie had actual Unreal Engine 4 shots in the final film.
Yeah, the thing that brought us to kind of in virtual reality running these things was the Meet Mike project, which Epic Games was one of the biggest contributors to. The fellow that you see, Meet Mike, Mike is actually Mike Seymour, who is a journalist for fxguide.com and writes some of the best articles you can read. Like, I learned a lot about how they finally did Blade Runner 2049 by reading FX Guide and Mike Seymour. We had scanned Mike in our Lightstage really extensively, not specifically for the Meet Mike project, but for something that Chaos Labs put together called the Digital Human League. And they wanted one of their projects to be a wiki human, which is, let's actually get some of the best Lightstage scans that we can get of somebody. Let's go to Disney Research and get the best eye scans that we can. Let's figure out all the people who are playing in this digital human space and get them to kind of work together outside of their normal paid projects to do this. And so all of those scans of Mike Seymour were sitting around as the WikiHuman project when he got the idea for part of his PhD thesis, let's create real-time in VR, Mike. And that's really the thing that was like the next step. Like, we can do digital IRA in real time. Can we do it in real time in stereo at 90 frames per second and drive it live with somebody's performance? And that's things that 3Lateral and Cubic Motion contributed to. And Kim Libreri, the mastermind at Epic Games, is often good at puppet mastering all of these different technologies together to try to create a result. And I was very honored I got to be one of the people interviewed by the Digital Mike character there. My avatar didn't get to look nearly as good as his because we used a kind of a sort of like a cartoony avatar technology for that. But I think it was a great achievement. I think we need to go a little bit further in terms of the realism of the animation. I had a little bone to pick about the teeth shading. I think the shadows got too dark between the teeth. But it was a huge achievement and something that happened at least a year or two earlier than I was expecting it to.
What impact will gamers see, starting with Call of Duty World War II, but even moving forward with more and more actors being involved in these games? How will they look different than what you're used to seeing when you're traditionally playing a video game?
What I'm hoping is that with video games having better digital human technology, that the stories will get better, the emotional engagement will get better, and the things that you can do in these virtual worlds that are the video games become deeper and more interesting. I think one of the reasons that video games are so violent is that, with kind of simple graphics, what can you do other than, simulate, this thing firing a missile at that thing? And that's kind of translated up until now, where it's now like, Grand Theft Auto, people shooting each other, running each other over. But once we actually have like realistic emotions on faces, once we have some sort of interactivity of the characters, I think that the way that you can interact with people is going to be much more like you'd interact with your friends, your colleagues, people that you meet on the street in the real world, but in fantastic situations that you can create in video games. And hopefully it's not just about how many headshots you can get in any given level.